everyone, thank you so much for clicking onto the video. Today's learning objective is to look at the core practical, which is the analysis of some inorganic and organic unknowns. So this is building on our core practical 7. Now we're going to have a look at a core practical, which is the analysis of some inorganic and organic unknowns. So our method comes in lots of stages because we're testing for different things each time. So firstly, we're going to look at some flame tests. And the overall method we have for this is that firstly we use a clean nichrome wire to mix a sample of a solid compound with a few drops of concentrated hydrochloric acid. We then hold this wire at the edge of a hot Bunsen burner flame and observe the colour. To test for cations or identify cations, we dissolve the unknown substance in water and then add aqueous sodium hydroxide drop by drop until there is no further change. When we test for halide ions, we dissolve the unknown substance in distilled water, add a few drops of dilute nitric acid to the solution, and then a few drops of silver nitrate solution, and then we record the colour of any precipitate formed. And the identity of the halide can be confirmed by adding aqueous ammonia. Then we can test for sulfate ions, so we dissolve the unknown substance in distilled water and add a few drops of dilute hydrochloric acid, and then barium chloride. And the formation of a white precipitate of barium sulfate will confirm the presence of sulfate ions. And then going on to testing for carbonate ions, we can add dilute hydrochloric acid to a small amount of the solid substance in a test tube, and then we bubble any gas evolved through lime water. And if this lime water then forms a white precipitate, then this confirms that carbonate ions were originally present in step 1. And then testing for an aldehyde, we can prepare some Tollens reagent by pouring 1 centimeters cubed of silver nitrate solution into a test tube and adding 1 drop of sodium hydroxide solution to the silver nitrate solution. We then dissolve this precipitate formed by adding ammonia solution dropwise until the precipitate just dissolves. And then we can add 10 drops of the unknown organic substance to the test tube, and then we can stand the tube in a beaker of just boiled water and leave for 5 minutes. We then record the observations, and if an aldehyde group is present, then a silver mirror will form on the inside of the test tube. Then going on to testing for carboxylic acid, we can mix some unknown substance with an equal amount of ethanol and then add a few drops of concentrated sulfuric acid. We then heat the mixture by standing the test tube in a beaker of hot water and then pour the reaction mixture into aqueous sodium carbonate in a boiling tube. And if the unknown substance is a carboxylic acid, then there'll be an ester smell like glue or pear drops. Then finally, testing for alkenes, we add approximately 1 centimeters cubed of bromine water to the unknown organic substance in a test tube, and then we put a stopper in it and then gently shake. And if an alkene is present, then the colour will change from orange-brown to colourless. So we're going to have a further look into all of these tests. So we're firstly going to look at the sulfate ions. So why this happens is that we have Ba2 plus ions, and they react with sulfate ions, which could be in the unknown substance, and they can form barium sulfate, which is a solid, it's a precipitate, and that's the white solid that we see. So that's our test for sulfates, is we add some barium chloride. And the reason we use some dilute hydrochloric acid is so that we can get rid of barium carbonate is also a white solid, and so this would give a false positive result. And then for testing for carbonates, because we add some hydrochloric acid, whenever we add an acid with a carbonate, we can form carbon dioxide, a salt, and water. And so it's the carbon dioxide that is the gas, and this is bubbled through lime water. And we know that when we test for carbon dioxide with lime water, it should turn cloudy or form a white precipitate. And so this will confirm that we have carbonate ions in the original substance. And then testing for an aldehyde. So the silver is dissolved in the ammonia, and so the ion we have in Tollens reagent is Ag and then NH32+. And then when it's added with an aldehyde, it can oxidize this aldehyde, and so it gets reduced itself. So then because it becomes reduced, we add an electron, and so we form solid silver and then 2 ammonias. And it's this silver which is the silver mirror. So this is why we have a silver mirror forming when we add an aldehyde to Tollens reagent. And then for testing for carboxylic acid, because we're adding ethanol, which is an alcohol, whenever we add an alcohol with a carboxylic acid and heat it, we go through esterification, so we form an ester. And so This is why we get the ester smell. And then finally, testing for alkenes. When we add bromine water, the colour should change from orange-brown to colourless. So now we're going to look a bit further into flame tests, identifying cations, and testing for halide ions. So here we have 3 tables of some results that we could get. So if we have the flame colour of yellow, then this will be a sodium. So this will tell us that it's a sodium ion present. Lilac is potassium, and then yellow-red is calcium. Pale green is barium, red is lithium or strontium, and then red-violet is rubidium. And then looking at cations, we have chromium 3+, so this gives a green precipitate when adding aqueous sodium hydroxide, and when we add excess of this aqueous sodium hydroxide, this precipitate then dissolves to a green solution. So this is what we learned in the transition metals video. And so for Fe2+, we then have a green precipitate when we add aqueous sodium hydroxide, and it turns a bit brown on exposure to air because it goes through oxidation. And then after adding an excess of aqueous sodium hydroxide, the precipitate is insoluble, so nothing actually happens. And then we have iron 3+, and then cobalt, and then copper 2+. So if you can't remember any of these results, then please go back to the transition metals video to have a look. And then we have group 2 cations, so we have magnesium 2+, calcium 2+, and barium 2+. So when we add aqueous sodium hydroxide, we form a white precipitate, and this precipitate is insoluble in an excess. And then group 1 cations won't have any observations when adding sodium hydroxide. And then finally, looking at the halide ion table, so we have a chloride ion, which will form a white precipitate. Bromide ion will form a cream precipitate, and the iodide ion will form. And then when we add dilute aqueous ammonia, the chloride is soluble whilst the bromide and iodide aren't soluble. And then when we add concentrated ammonia, we have that the bromide is soluble but the iodide is not.